Hi there, this is session 28 of programming from the very basics using Python. In the previous session, I introduced you to how to define a function and different ways you can define functions when it comes to taking arguments. I told you how you can take default arguments or non-default arguments and the syntax rules for them. I also told you how to write a function that can take variable positional arguments and variable keyword arguments too. And I also told you how to call a function where passing positional arguments and keyword arguments as such. And I told you the syntax grammar for it and with a lot of simple examples and use cases. In this session, we will learn first about variable scope. How do functions deal with scope of variables? And I'll also try introducing you to inner functions or nested functions as you might call it. And if time permits, in this 1 hour video, I will also try to introduce you to the lambda expressions, or maybe I might talk about it in the next session. We will wait and watch. Anyways, so let's get started with some important topic about variables. We already know that when you define a variable like this, it's an identifier. You said A is an identifier to an object, right? So all variables are identifiers, and these are labels to objects. I keep repeating that. When you type A is equal to 100, this variable is right now scoped at the level of a module. So when I say a level of a module, what I mean to say is that all variables that you create outside a function at the top level, these become attributes of the currently running module, which is very likely main in this case. You can find out what module you're running on right now by typing this special identifier out, which is name. And okay, let me just select the Python runtime and run this. You can see it shows up as main. So I've discussed about this concept of modules in a session related to modules. I guess it's a couple of sessions back, so I lost track of the session number, but I think I will add the cards in this video if time permits slowly. And when I did discuss about modules, I told you that all your Python modules run as a module by name main, which is main with under attributes, and all the variables that you create inside this module, all the global variables that you might call, are ultimately attributes of the main module. Just to reiterate here, if I just go to the Python prompt and just go to the Python shell in this place, and let's launch a basic Python runtime. So I launch the Python runtime, and let's try this. Let's try maybe user is equal to John, and let me put something else. Like say config is equal to test.cfg. All these are just arbitrary data, which I'm trying to, it's a string which I'm trying to assign to identify it here. These are just two variables. We can see that user and config are just two variables that represent strings, as you can see here. I can also define a function. I can just define a function called greet. And maybe it just greets a user and does nothing else. And greet also happens to be an identifier, which is representing a function by name greet. You can also import a module. Let me just try to import a module that we've been using for some time now called time module, which you can use time.ctime or local time. We've been using them to find out what time it is, right? Now, all these are definitions in the current scope. As I told you, all these are global variables. We can just type globals to as a built-in function to return the namespace dictionary of the main module, which just prints this whole details that you see here. You can see that it shows name is main, and there's something called doc, which is none, package. All these are dunder attributes that you can for now ignore. And however, you can see something called user, which is John, config is test.cfg, greet references a function object by name greet, and time refers to a module by name time, which you can see here. And this globals function actually extracts the module dictionary. But the fact is that when you're right now inside the main module, you cannot access the main module directly because there is no identifier to reference the current module. That's main. But if you really want to access the main module, you can do so manually by just using import main like this. And when you do so, what it does is it creates an identifier called main and this points out to the module that's currently running this code. And as you know, that all of your Python code ultimately lives in some module or the other. Modules are the way your Python programs are actually structured. Think of them as the top level structure of your Python program. Just to summarize, think of module as a box, and all of your Python ingredients which fall into your Python code are inside that box. And maybe you will live in a box, house, let's say. I'm living in a house right now, and this house is a module for me. So I'm right now inside my house. So when I'm inside my house, I can access all the equipments and all the gadgets and all the stuff around me, like the mouse and the remote control and the keyboard and my computer and the laptop, and all the stuff is just in front of me. I live in the same scope as all of the other ingredients which are there here, so it's quite easy to access. But if I want to access an equipment in my neighbor's house, let's assume that my neighbor is in a separate house, of course, and want to access some equipment in my neighbor's house. Maybe I want to just borrow a charger from my neighbor. Maybe my charger is just gone bad to charge my mobile phone or something. I need to go and access my neighbor, which is his house. That's a module. And I can go and access his charger, assuming that is willing, obviously, and I can get his charger. The point is, if at all I have a charger in my house, a phone charger, let's assume it's in a current scope. I can just call it as charger. But how to access my neighbor's charger? It's a neighbor.charger. You get the picture there. So neighbor is maybe the name I'm giving to my neighbor's house, dot charger. So that's an attribute. So that charger is in his namespace, it's a global data in his namespace, but it's confined to his house, and what is in my house is confined to my house. So think of modules as a means of packaging all the definitions inside a particular scope, right? So that's what these global variables are. So when I actually type import main, I'm trying to get access to main like an external person, right? I'm inside main right now. This REPL is running as main. You can actually print it out. You just say print of name. But just that I want to access this particular current scope from an external perspective. So I load it as a module. The moment you do that, you can just look up main.dict. You can get access to the mains dictionary. And this dictionary is what globals function returns anyways. I told you that globals just gets the access to the current modules dictionary and just returns it as is. So when you actually look up some names like say user, what Python resolves this as, it will resolve it as the current module, which is main dot dictionary of user. It's all the same. Dict is a dictionary. I know the key. The key is user. I get the value for it. Let me try something interesting. If at all I add a new key in the dictionary, so I'm just trying to do this. I'll just say main.dict of, let's add a new name here, a new variable. Let's assume I'll put a new key that is. Let's call this key as, let's call this as maybe phone number is equal to some number. Let's assume. Assuming there's some kind of a random number, but it doesn't matter. So we just try to add this into the dictionary. And now we can see that it's now magically available as a variable. You can see that. So you can just see that every time I'm defining a variable in a module, what really happens is that the name of the variable is added as the key in a dictionary. The value would correspond to the object that it refers to. And that's exactly how global variables are represented. There are just two scopes primarily that you should know about. The local scope, when you're inside a function, and then you have a global scope based on where the function is invoked, based on which module the function belongs to. So this is called as a local and global scope as such. So if you look at the scope, there are four different scopes that are available. We call them as local, enclosed, global, and built-in. There are 4 levels, but for now, I'm just going to focus on the global and the local scope and show you some differences. Then I'll introduce you to the other scopes that and how they matter. Now, let's go ahead with creating a function here. So this is a global variable, and this time, instead of doing this in a Jupyter notebook, I think I would put this in a separate .py file and run them So this way you get a more clear feel in a separate program. So what I'll do right now, I'm just going to create a new file, and I'm just going to select Python file here. And here, there's an empty file this time. I'm just going to call this as global variables.py. Global var.py. And then let me just add a variable. Let's say a is equal to 100. And I'm going to define a function here. Let's call this function as silly as I can. I'll just call this as testfn inside this .py file. And inside testfn, I'm just going to put a print message. I'm just going to type in testfn a equals, let me just use the format literal string syntax. I'll use the f string, in which I'll use int testfn curly braces a equals right here. And this time I'm just going to print this is outside the function. The moment I unindent this code, it goes outside the function. And in here, I'm just going to use in main. I'm just going to call this main program as main, right? So let's call it in main a equals this, and I'm going to call testfn function. Or maybe I can just put this on top. It doesn't matter. So it doesn't matter where you put it, right? Let me call the function first, so you'll just know what the function sees that variable as and how main sees it. So when I run this code now, oh, I'm in the right folder. Yes. Just going to call this. Okay, I'll leave this code in this corner, and you can see this code in this corner, and we're going to type Python global var.py. And as you can see here, a variable that's defined outside a function can be accessed inside a function anyways. And this kind of an access is called as a global scope, which means that all definitions that are outside a function at the module level are available inside that module scope without any restrictions, I would say. So you can access this particular function access this particular variable from inside this function without a problem. Now I'm going to make some change here. So what I'll do is I'm going to make a new file. I'm going to create a new file. I know this file is going to be very, very small. It's a good idea to put it in a notebook, but every time I define a variable in a notebook in one cell, it's going to be going down all the way through. So you have to restart it. So I want to keep this program completely self-contained. So the moment the program is run, it starts afresh. It doesn't carry forward from any of the previous cells or so. So that's the reason I'm using the .py file for this demonstration. So I'm just going to create a new file here. I'm going to save this file as, I'll call this as global var modify. Now this time, inside this testfn function, I'm just going to go ahead and do this. I'm going to say a is equal to 200. And now is an interesting part. I just said I'm just trying to change this variable from inside a function. So inside testfn, I'm setting the value of a to 200. I'm printing the value of a first, and then I'm trying to change the value to it. I'm trying to set it 200. So what do you think would be the outcome? So when I run this code, what do you think is the outcome? Well, based on what language background you come from, you might have different answers. Some of you might say, okay, you changed to 200, so it's going to be like testfn shows up 200, main shows up 200. That's one possibility. Another possibility would be that, first the value is 100, so testfn is going to print that value which is 100 earlier, the earlier value. That's a global variable's value right now, 100. And because testfn sets it 200, in main it prints the values 200. So the value output could be 100 followed by 200. Somebody might say, oh, it's going to be 200, 200. Some of you might say, okay, it's going to be 100, and it could be 100 and 100. Maybe because you just try to access this variable. It's a global variable at this moment, which is going to print 100. And when I call this function, whatever function changes are there, it's local to the function. So it's not affecting the global variable. So it's going to print 100. So the probabilities could be 100, 100, 200, 200, or maybe 100, 200. There is an ambiguity. It's very difficult to decide which one is it, right? And I've told you that in Python, There's a Zen that says, in the face of ambiguity, refuse the temptation to guess. Yes. So if you try running this program, global var mar modify.py, you can see it throws up an error. And the error is pretty strange. You can observe that the error is in, I'll tell you which line number is it. The error is in this line, which has got to do with the print statement rather, not a is equal to 200. The error is in this line number, which is line number 4. And line number 4 is this one. And what is this error? The error is actually unbound local error. It's not name error, type error, value error, or anything else, right? This is quite new. We have never seen this error before, right? So if you just look at it, it says unbound local error cannot access local variable a where it is not associated with a value. Wow. So what's really going on? Let me do one thing. I'm just going to save this as another file just to keep the trail so you can just see what happens when you run this file. What happens if I make a modification? It's going to be another file. So I'm just going to save this as another file with, just make it as modify2.py. Just put an _2 there. It's the second version of this file. All I'm going to do is that I'm going to take this print statement off from here and then put it below. Now you can see that in testfn, I set the value to 200 first. Set the value of a to 200 first. Then I'm going to print it. And I'm going to call testfn and I'm going to call the print function in the main. Now let me save this and run it now. This seems to have no problem, and you can see the outcome of it. You can see that testfn a is 200 and in main a is 100. Now this answers the question somewhat, but you need to understand what's going to happen when you define something inside a function. Now here's an important rule that I would want to make inside this place here in the Jupyter notebook. Let me add an interesting statement here. And this is a very, very important one. So I'm going to put it in like a header. I would just say all definitions within a function body creates a local scope. All definitions inside a function body creates a local scope. What do I mean by that? Well, what I mean here is that going back to the old code, which was this file, which I have here, when I define anything inside a function, there's a definition. When I said a is equal to 200, I'm defining something here. Every single definition that you put up in a function body creates a local scope. That's this a is going to be a local variable. Now, because this a is a local variable, you're trying to access this local variable before definition. Interesting. How does Python figure out that it has to access local variable? How does it travel back in time? This is a kind of proof to show you that Python is a compiled, interpreted language. When the code is getting compiled, when the bytecode is being generated when you're running this code, during the bytecode generation, that's during compilation, it realized that there was a definition inside this function body, and this a is made as a local scope during compilation. What it means is that it's trying to indicate that all references to a in this function, no matter where it happens, during compile time, the compiler sort of binds it to a scope inside a function. Let's say every function would be associated with something called as a frame object, which is equivalent to the stack frames that you would have heard about in statically typed language like C, which maintains the state of the function. The function states are local to the function. So anything that you make inside the function, any changes you make in the function is only applicable to the function scope and should not affect outside the function. That's called a local scope. When I say what is a local scope, it's a state that is only accessible within a function body during the function execution. That's a state which is private to that function. It's private. That means whatever changes the function makes is not visible outside. It does not affect anything outside, right? All the variables that you define inside a function create a variable which is scoped locally to the function. So how these variables are represented? Variables are ultimately names. These are identifiers, right? When I look for A in testfn, rather than looking up the mains dictionaries A, it looks up the testfn's own dictionary, which is not visible to us, unfortunately, within its frame for the value A. The compiler generates a code that binds it that way, which means that because this particular A is going to be accessed from the function's own locally scoped, we call them as cellvars. That's what it's labeled inside or called inside the function attributes. So it's going to access it from there. So it's not going to access, resolve it to the global variable. Now the catch is that the compile time just says that all access to A should come from the function local scope, which is part of the frame object from the cellvars. Now the cellvars of the function will have a label called A, but it is not yet initialized with a value when the function starts. The moment you define A is equal to something, that's where that's filled in and it has an entry in the frame object. So because of this, if you try to access A before definition inside a function, this raises this strange error, which we know as the unbound local error. It says cannot access local variable A where it's not associated with any value. That means you're trying to access a variable before definition. If you try to access a global variable before definition, you will get a name error, right? If I try to access any variable, like say if I try to access maybe B here, I'll try to access another variable called B. Let's forget about this. If I try to access something called B here, I'm just going to put a variable called B. And I'm sure there's no variable called B defined in this code. But try to run this now. The first variant. You can see it shows name error because I have not defined B anywhere inside the function. So it's not going to add an entry for the function. It's not going to bind it to the function during compile time. So during runtime, when you try to access B, it's not going to look up in the function scope. It's not going to look up in the local scope. It's going to see outside in the local scope and it tries to look up in the global variables list. It doesn't find it there. It raises name error. But in this case, I try to access A, but A is now bound locally by the compile time when Python code is getting compiled by the compiler in memory to the bytecode. So therefore, during execution, when you try to look for the value A, it's going to try to get the local access, and when the local variable is not yet being initialized, that is why you get this error called unbound local error. So I guess you got this right? So this is the first rule that you should know. That is, all definitions inside a function creates a local scope. All definitions. When I mean all definitions, it's not just that you define variable. Importing a module is a definition. Defining another function, that also is a definition. Defining a class, that also is definition. And strangely, in Python, you can define a class inside a function. You can have a class definition inside a function. It's perfectly valid. Definition is just a definition after all. It's just a statement. It's a compound statement. Compound statements can be used in all the places. There are no strict rules about it. You can also import a module inside a function. Now that module, access to the module is scoped only inside the function. It's not going to be visible outside. I'll show another example to this. We call this as the local imports. So I'll save this file as local import example. .py. In here, I'm going to define a function called testfn. And inside this function, I'm going to type import time. I import a time module inside a function body. Now, the act of importing time will give you access to the module or load that module in memory if it's not already loaded, and then creates an identifier in the current scope with the name time that represents the module. Now, because I put this statement inside a function body, The scope is local to the function, which means that you can actually use time.localTime inside this function, or maybe I'll use ctime, which is more convenient. It just prints a human readable time in this case. And let me just make it more detailed. It says int testfn time equals. I'm just going to use time.ctime. So I'm trying to access a module and module's members by the module, through the module, that is, inside a function here. But then, if I try to do this outside, when I try to say in main, time is equal to, say time.ctime, this won't work. Let's try it out. But I can see that it throws an error here. I didn't call testfn. I just called, you can see that I just called the print function. I did not call the function. Remember, I just defined the function. I didn't call it, because you don't call the function body is not going to be executed. But if you try to call the function here, let's say testfn, you can see that the line from testfn, that's the in testfn time is equal to, will be printed, but the print statement that's at the end, that last line, that's the sixth line, that will throw an error. But you can see that right here. In testfn, I was able to access time. But outside testfn, there's a main, I did access time, it doesn't work. Which means time as a module, the access to time as a module is scoped locally, which you can see right here. So if you want to access in this main function, in the main code, you still need to import time at the global scope. That's the reason why most people have the habit of importing module at the beginning of the program, so you can access it anywhere in your code without any ambiguity. But this is something where I am a little biased, and maybe I don't agree with a large part of the community, let's say. So I might look like a completely outlier here. I personally prefer local imports in places that make real sense. If I have a function which is going to be fully independent, a completely reusable function, which I can use it anywhere, and this function uses a module for its own use and doesn't care about that module being used by others, we don't know whether that module is used by any other code path. Maybe it's used uniquely by this function, for all you know. It's a good idea to just import the module inside the function scope and access all the members of the module inside the function alone. The outside world doesn't have to worry about it. And this actually reduces the global namespace clutter. What is a global namespace clutter? The lesser items you have on your table, the more clean and organized you'll feel. If you have a lot of clutter on your table, it gets a little messy. Searching for things can be a little difficult, and troubleshooting any issues can be more difficult if you have a lot of wires and things connected over here, right? So when you're building any program, you want to keep the namespace clutter to the absolute minimum. I've seen a lot of Python code. What people do is that when you look at the Python source code, it's with many projects and a lot of projects. And it comes from the habit from other languages, perhaps, because in other languages, like in Java, you still use import there. The import keyword is there even in Java, right? But you import packages there. It's a totally different thing, right? It also provides a namespace, but how it works is totally different. You can't just put import wherever you like. You have to put it in the beginning of your program, even before you define your classes, largely. That's the case with many other languages too. You use import, require, use. These are the keywords to access other libraries or modules. In C language, of course, you don't really load libraries in your program in the beginning. The hash includes are sort of not the same, but they act something similar. Basically, they give you access to declarations during compile time for some external library functions that you might end up using. That's what you get when you use hash include stdi.h or stdlib.h and so on. But ultimately, when you're building your program, you need to link it with the library appropriately. That's a different story, but you put the hash includes in the beginning. The same kind of habit is gone through in Python, where people put all the imports in the beginning. But I found this really innovative that import is treated like just any other statement. And that is a good thing because if you believe that a module is used just by one function and nobody else in your code, the reason for importing at the top level doesn't make sense to me. So some people might argue about it. Yeah, you post in comments if you have your argument there. Let's debate it out. But that's what I feel. That's what my biases are. So I would like local imports for any modules that are scoped, that needs to be scoped only inside a function. So module names are scoped to the function. Now some of you might even argue, what if there are 10 functions and all the 10 functions are going to be calling import time, import time, import time all over the place, and that doesn't look good, right? That's a point in time where you want to import time at the top level and then use them in 10 functions. It's all the act of reusability. If you believe that a module that you're using is only private to a function, nobody else needs it, local imports should just look fine and they make it more cleaner. So as I told you, when I look at a lot of Python projects, Python source code, I've seen a lot of imports. The first 20, 30 lines of just import, 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 from module import this, from module import this. But looking at that, I have no idea where are they going to use them, which function is going to use them. But tomorrow, if that function is being refactored, no longer to depend on a module, but maybe another module, you just don't have to modify that function which lives somewhere down in the source code, but you have to go back and find out where the imports are and change them, or expect your IDE to do the job. That's what many people prefer. Most smart IDEs like VS Code can figure it out and say, oh, okay, do you want me to remove that import? Do you want me to add that import? They can do that. You can customize your IDEs to do that. But you don't need that complexity at all if you know for sure that here's a function that requires these modules to work for its own, and this function is fully reusable. And I believe that these modules are used mostly only by this function in this scope, in this module. None of the functions might require them. Then it's a perfectly good idea to use local imports. You can also load a module conditionally. That means you can use if some condition import time, else import something else. It might not make sense for time, but one of the cases I used it actually is trying to maneuver platform intricacies. Let's say there's a Python code that has to work on Windows and it has to work on Linux. When I work on Windows, I want to load a different library which provides certain functionality. But when I work on Linux, the same code should load another module that provides a similar interface but with a different alternate implementation. You can perfectly do that using local imports with conditions. So all of these are things that can be done understanding the concept of scope. All right, so I detoured a bit. I talked about local imports. Let's come back to the scope here. So I talked about how this is treated as a global variable and how this definition is treated as a local variable and why this code throws an error because you're trying to access a local variable before definition. Now, having said that, now if I try to show you, what if I want to modify a global variable from inside a function? I have a function here. I don't want to create a new variable called a, scoped locally. What I really want to do is that I want to modify this global variable from inside a function. Can you do that? Well, you can. But should you do that? No, you should not. All right. Now you might ask me, what's wrong with that? Well, here's the thing. When you design functions, you should aim to make your functions pure functions. So what are pure functions? Now is the time to tell you that. Let me go back to the, where's my VS? Okay, I need to scroll this side, I guess. Okay, let me close all these things. So, all right. Yeah, save it, no problem, all right. I shall now introduce your concept called pure functions. Functions versus functions with side effects. When you look at function definition, this is a generic concept. It's applicable to any programming language. It's not just Python specific. You can apply, this concept can be applied in C or C++ or any language of your choice. I'm not sure if you can do it in Python. You cannot do it in Java per se. There are no functions in Java. That's a bad thing, right? That's a limitation of the language. But when you have a function, you can treat a function as a pure function or a function with side effect. What is a function, or what is a pure function, or what is a function with side effect? A pure function is a function that does not alter or largely depend on its external scope. For pure functions that do not alter or depend on external scope, they are mostly self-contained, and whatever they do, whatever state they maintain, is purely local to them. And once a function finishes execution, all the state is toned down. And that's what a pure function is. Let me give you an example. Let us say I have a function here. Let's call this square of x. And I'm just going to return x into x. This is a simplest example of a pure function. Why is that? This function, no matter how many times you call it, it does not create a variable or hoist a variable in the external scope. It does not hoist a global variable. It does not alter any global variable, right? And it does not remember itself being called earlier. You get my point? You call square as many number of times. You call it once, you call it twice, you call it thrice, you call with 2, you call the argument with 3, you call this with argument 10. It doesn't matter. Every call to square is like it's born again. It's just going to do the job and it dies out. So when it leaves, the state of the external world to it is unaltered. And that is a trait of a pure function. So when I call square how many ever times I want, it does not do much. You can just see that. I can say square of 2 or square of 3 or square of any number. Let's say 25. It doesn't matter. No matter how many times you call it, it does not remember it was called earlier with the number. It does not know it was called earlier. It does not maintain any state across calls. It does not maintain any state outside its scope to know how many times it's called or what value it is called or store the result somewhere. None of the stuff. And this is the simplest example of how a pure function must work. And then there are functions with side effects. I'm going to show you another variant of this function. Let's call this a square list this time. And let's assume this takes a list as an argument. This takes, let's call this as num list as an argument. And all it does is, it's going to return a new list of squares of numbers of whatever is passed in num list. So I want to do that by using v into v for v in num list. Now when I try to call this function, I say r is equal to square list of 10, 20, 30, 40. Try to print r. You get the outcome. Hang on, I'll remove this code. This code is not really required in this case. You can call it how many ever times you want. Every time you call it, it just takes in an argument. Based on the argument with the list, it iterates over it, creates a new list with all the squares of the numbers and returns it. And its job is done. It does not maintain any state across calls. It does not carry forward states. It does not alter anything outside its scope. This is also a pure function. When this is also an example of a pure function. So just to point you out, let's say that a is equal to these numbers, let's say 2, 5, 7, and 3, let's assume. And I'm just going to call this like this. Let's say I want to call r is equal to square list of a. I'm going to print r. I'm going to print a. And you can see the outcome of it. A is still unaltered when you print it. A is still unaltered. Now let's write a program that works differently, or write a function that works differently. Now let's assume that this particular function doesn't return a list, but rather alters a list passed on to it. Let's say I call for I comma v in enumerate of numList. You can see that this is an example of the right use case of enumerate. By the way, when you want to iterate over a list and alter its values while you're iterating over it, this is how you do it. So you can actually do this by doing numList of I equals v into v, and maybe just return numList itself in this case. But this is an example of a function with side effect. An example for a function with side effect. When you try running this code, I initialize this list to have these numbers. And when I now pass it on to this particular square list, it does return a result, no doubt. But what does it do? It modifies the original list and returns it back. That's what it does. So the original list is lost after I call this. Just see this. Interesting. You call this function another time. You call this function yet another time. You can see what happens. It sort of carries forward state because it maintains the state outside its scope. Right? Outside its scope. In this case, it's modified the global variable. Not really global variable. Mutated the list outside its scope. And therefore, this is an example for a function with side effect. Now, is this a good idea or a bad idea? Well, think about it this way. Functions are supposed to be like in mathematics. You would learn in algebra that they say y is equal to f of x. X is a variable that's passed as an input to the function. And the function is supposed to take in the value from x and do some computation and return y. You should never have a function that goes and alters x. You don't want to alter the input passed on to you. That's a bad design. But this is more frequently done in languages like C because of the limitations of how their function grammar works. So you have scenarios in C where you actually pass address of a variable. And why you do that? Address of a data structure, right? And then you expect the function to access the address and fill it up with something. So you're passing input to a function and you expect the function to modify that input. That's a very common norm in C. But if you live in the Python world, you shouldn't do that. That's really a bad thing because this code is no longer concurrency safe. So I'll talk about concurrency in a while. But it's not concurrency safe. And maybe you have a code. What if I don't pass a list and I pass a tuple? This is definitely going to fail. This is going to fail. Because though I call this function square list, it doesn't really check what type it is. You can also enumerate over a tuple rather than list, and this breaks. But the previous code wouldn't break. This doesn't break because it's a pure function. It doesn't alter anything passed on as input. So you pass in a tuple, no problem. It's just going to work. So if I'm just going to remove these square brackets, down there's a tuple, and still you can see the output is a list, but the input can be anything, right? So this is how you should design your functions. When you think you need a function that has to maintain state across calls, the chances are that you have two functions, function A and function B. Function A sort of has some relationship with function B. Maybe function A creates a connection to a remote database. So you call connect, and it maintains a connection. And you want to disconnect from a database. You want to call disconnect or close. You cannot call close when you're not connected. So these are two functions which are sort of coupled to each other, right? They're sharing a state amongst themselves. So in this kind of scenario, what you'll normally do is that you would create a global variable. You'll make one function, alter the global state, and the other function is going to depend on it and work accordingly, right? So if you run some C programming, it's quite common to do that. where you have some couple of global variables that you define, and you have a few functions which are going to share state by sharing that global variable or a global data structure. This is something that you should avoid completely in Python. Avoid. Though this feature is available, you can. Python doesn't restrict you as a language. How you design your program is completely up to you. You can build a totally horribly designed code in Python and then complain that Python is slow and sluggish and unmaintainable. And it's because you've not followed the right rules. You're not followed by the rule book, right? Some languages will restrict you from breaking the rules, but Python doesn't do that. In terms of language design, the way you write your program is completely, you're free to design logic the way you want. So it gives you all the abilities. But having said that, you should know what is a good thing to do, what is not really a good thing to do. The not a good thing is done for quick and dirty kind of scripts which you write in Python, which you don't care about much after a while. Then it's fine. But otherwise, for well-written programs, which has to be maintained in the long run, follow these rules. Every single function that you define, you have to make sure these functions do not alter anything outside their scope. Make sure of that. Never try to manipulate a dictionary or a list passed on as an argument. You can, but don't do it. This will create a lot of annoyances, especially when you work in a team. This happens in a lot of companies. I've seen a lot of people complain about it when they say, I wrote this kind of a configuration in a dictionary and some function written by some other developer has messed up my dictionary and I don't know what to do. And the other person had to find a tough time troubleshooting it, finding out who is the culprit, which function, written by whom. When you work as multiple developers, like 10 different developers writing 10 different pieces of code, which falls in a single framework, and they also share some common state, which could be something like a configuration or statistics kind of a global data structure. This is what happens. And that's exactly the reason why people prefer the object-oriented programming, where we have this benefit of encapsulation. So what do you do? If you have some data that you don't want anyone to modify, you encapsulate it and make it difficult for others to access it. You have all these private and protected and all this kind of qualifiers in other language. You don't have that in Python. Let's talk about that later. But you should know by design, as long as you create functions that are pure by nature, you can avoid all this kind of code that becomes a spaghetti after a while, right? So anyways, a lot of rant. Let's come back to the thing. I should talk about, I told you about the global variables, right? So I told you, can you modify a global variable from inside a function? You can. The way you do that is by using a global qualifier. So I'm going to save this file as, not this. What was it? Okay, this one. Let's, sometimes the file save as gets it totally wrong. All right, let's call this global modify 3 this time. Now I have a global variable a is equal to 100. And I believe that this is a function which wants to access the global variable and also modify it. So if I want to do that, I can, let me do this. You know, this will cause a unbound local error. If you remember, you run this as is. You just save this and run this now. It shows an unbound local error. Let me just confirm that. Yeah, you can see that. It shows unbound local error, cannot access local variable A, where it is not associated with a value. I think that's scrolled out, but when you go back and read it, you'll see it. It shows, maybe my face is masking it. Yeah. So it shows cannot access local variable A, where A is, okay, where did it go? Okay, associated with the value. Yeah, that's scrolled out. You can see that, right? All right. Anyways, let's come back to this code. And this time, what I'm going to do, I know what I'm doing. So I just want to modify the global variable. It's a very simple script. I don't care about reusability, readability, maintainability, and all that. It's a use and throw kind of a code. In such case, you can actually use this qualifier called global, the statement. When you say global A, It's more like a compile time hint. The moment you type global A here, when this code is getting compiled, the compiler, the Python compile time, and when it's parsing the program, the moment it sees this word global and a name here, it knows that all references to A, be it assignment to it or any other forms of definition or access to it, it's sort of hinting the compiler don't create a local binding to it. It stops from creating a local binding. So the compiler just ignores the fact that A would be defined. It doesn't create a local scope. So all access to A would now be global. So it just creates a global variable. So it's a global A here. I can actually look at this. I say A, it prints a global scope, and this will modify the global variable as a proof. You'll see that here when I run this program after this modification. Let me move this across here so you can see it happening. Interesting. Now we can see that the current value of A, which is the value of the global variable, is printed in testfn, which is A is equal to 100. In testfn, I set A to 200. Now in main, that's outside the function, the value of A in main, when I print it, you can see the value 200 being printed. So if you really want to modify a global variable from inside a function, at the beginning of the function body, at the first statements, you may need to declare them as global. This is a kind of a declaration. When you're declaring using global, you're not declaring the scope, not the type. Remember, scope. So you can declare a scope of a variable during compile time by using this technique. The global variable also has a global directive, I would say rather, also has another feature. You can hoist variables into the global scope. We call this as variable hoisting. I'll show you an example for that. It's a variable hoisting example. So it's like hoisting a flag or whatever. Use that word, right? So this time I don't have a variable which is globally defined, right? Start. And now let me put this in here. Let me keep it simple. Okay, just to keep it simple. If I just try to call, I'm not calling testfn this time. I just define testfn. I'm not invoking it. If I try to call in the print function and try to access a variable called A in this code, it's not going to work because I've not defined this variable globally, right? So when I run this program now, you can see that namer A is not defined. But now, if I call testfn, I call this function, and then try to access a variable, just see what happens. Is this a good thing? No, this is a horrible thing in my opinion. This is a dangerous thing to do. The last thing you want is just dump variables into the global namespace. Not good. It's like dumping garbage on the streets. You don't want to do that. You don't want to spoil the place outside your home. You don't want to do that, right? So you don't want to spoil or change the public utility, right? So that's what you should know here. So this is a load for people who come from languages like JavaScript or Perl. They have the habit of doing it. They create a function that sort of hoists variable in the global namespace, and the function just goes away, and then the global variable exists, and then you can access it elsewhere. It's cluttering the global namespace, but it's possible to do that using the global keyword. And I would recommend completely against it for good coding practices. So you want to follow a clean coding practice. Avoid all access to global qualifier. Don't use global qualifier in your code. And if you have any argument for you to say, I need global for this particular use case, I will counter argue and I will tell you the better way to design it. Let me know, right? So some people might say, oh, these are the use case where I need global here. You don't need it. So if you think you need global, it's because you're trying to carry forward states amongst function calls. In such a case, you're better off using classes and objects, right? Until unless there are some specific needs where you don't care about maintainability of code and you know what you're doing, that's fine. Python just gives it to you, right? You just need to figure yourself out and see whether you're going to write code that you want it to be maintainable or not. So this is what is the debate I had about global. But then there's also another kind of a scope that Python has, which caught my attention quite lately. I never even knew that it existed for quite a long time, actually, because I've never seen anyone using it, never seen any Python code using it, but it's sitting there. I got to know that when you look up the keywords in Python, when I looked up the Python syntax keywords, we just go to help in Python. Let me bring this around here. And in a Python prompt, when you type help, open close parenthesis, I told you this is the help prompt where you can get all direct help in the Python runtime. You type keywords. You see a lot of keywords in here. By now, you should have known almost every keyword, a few of them which I yet to cover: with, yield, try, raise, except. Yeah, the future sessions will see that. There's something called non-local. I was curious about what this non-local is. Something to do with scope, because there's global, non-local. It's not local, it says non-local. What do you mean by that? So I went and checked it up. I just typed non-local here. And it explains it. The non-local statement causes the listed identifiers to refer to previously bound variables in the nearest enclosing scope, excluding the globals. This is important because the default behavior for binding is to search the local namespace first. The statement allows encapsulated code to rebind variables outside of the local scope besides the global module scope. Okay, let me show you how this works. Let's call this non-local scope. Example. This time, I'm just going to use non-local A. I think the syntax grammar, let me just verify. You say non-local statement, non-local identifier. That's it, right? You just specify the scope that way. And yeah, I think that should do. I have non-local A, and if I try to use it as is at this moment, this will not work. This won't work. In fact, I can see there will be an error when I run this. It says no binding for non-local A found. So what's wrong with it? Okay, let me just say A is equal to 100 here now. A is equal to 100. And then let me try using A is equal to 200. Still, I think it shows some kind of an error here. Just try to find out. Print int stfn equals. I still get an error. It says no binding for no local A found. Or maybe I should define it outside, is it? It says it's illegal to define it here. Non-local declaration is not allowed in the module level. Okay, that's supposed to be done in a function. So I'm wrong even in here. So what is this all about? Let's try again. Let's say A is equal to 100. Or maybe I'll just try to use globally. And A is equal to 100 here. Seriously, I couldn't figure it out. Well, what's the issue here? Let's find out again. Previously bounded scope in the nearest enclosing scope, excluding the globals. Okay. This is to be used with enclosed functions, enclosing scope. I would say that it's mostly applicable on nested functions. Let me talk about nested functions. I'll revisit this, right? So I'll come to nested functions in a while. I think this got to nested functions. It works just like global, but it's only with nested functions, right? That's the reason why it's failing here. So maybe if you want to make it work, maybe if I just have another function here, let's say def2, for example, and define a is equal to 100, a is equal to 200 here, and if I define testfn, let me remove this global and try to use it in here. Now this would work. Say is equal to 300, and in here we try to print a, and let me try to call foo here. Yes, that's what it is, isn't it? But then did it really modify the value of a to, oh, I didn't call testfn. Let me call that. Okay, let me do this. Call testfn here and try to print it. Now we can see that. All right. In order to explain non-local, I should talk about nested functions. Let it be. Let this code be. I'll revisit this code when I talk about nested functions here. But first thing, you should know about local and global scope. Just know this for now. And use global qualifier in case. Use global declaratives inside your function to declare a variable as global scope variable, such that any assignments or any definitions of the variable will either be hoisted to the global namespace or it will modify the existing variable in the global namespace if you modify them henceforth in a function, right? And as I told you, as much as possible, avoid usage of that, right? There are absolutely no real use case for it. So the moment you try to alter any state outside a function scope, that function is now a function with side effect. You don't want that. Let's take some examples in real world. Let's not real world, in Python. Most of the built-in functions that we learned, most of them so far. Look at len. What does len do? You pass a list, returns the length of a list. Does it alter any state anywhere? Nope. Just give me a list or any iterable object or any collection, not iterable, any collection. It'll just walk through the collection, identify how many items are there, and returns a number. That's it. And it does not carry forward any state across calls, does not, modify any global variables, none of those things. That's a pure function. Len is a pure function. What about print? Even print is a pure function. When you call print with arguments to it, it just writes on to standard output, but that's about it. Some of you might argue at the operating system level, no, you're changing the state of the standard output. Yeah, yes. You are changing the state outside your program scope, apparently. But still, when you look at it as a function, it's a pure function, right? From the operating system standpoint, yes, you're modifying the stream, you're modifying the standard output, you're adding some new entries there, but that's fine. That's not our business. We focus on our program. From the program perspective, print is a pure function. What about input? Input is a pure function. It prints a prompt, gets user input, returns it, and that's done. No state is preserved, no state is changed outside its scope. Almost all the built-in functions which are there in Python, almost all of them are pure functions. There are a very small few number of them which are actually not pure functions. I'm yet to cover that. One thing that comes into mind is the open function to open a file. That's not a pure function. So if I call open, it is a file object, no doubt. But then you need to close it. Well, actually, open is also now a pure function. Sorry, open is also a pure function. It's modified. It no longer returns a file handle or so on. It just constructs a new object and gives it to you. It's a factory, right? We'll talk about that a little later. So, very important thing, try to keep your functions as pure functions as you can and avoid function with side effect. You'll have a lot of annoyances in maintainability because it leads to cohesion, a lot of tight coupling. It is obviously not concurrency safe when two threads are going to call this square list, right? The square list is going to alter things, right? It's going to alter things and throw it around, and that can be bad sometimes. So these are things you keep in mind. So these are things you should know related to global and local variables. The next thing I should obviously talk about is to revisit this. I should talk about nested functions. So let me just create a new file here. Let's say I define a function here. Let's call this function as testfn. And inside testfn, I define another function. Remember, function definition is a definition. Right? What do definitions do? They create a new identifier in that scope and they represent an object, right? So I define a function, let's call it as foo this time. And this foo function, I just print, this is foo. Now, outside, I cannot call foo. Try calling foo like this. Let me save this. Let me try calling foo. I'll just call this program, what I call it, nested functions. So I'll just, okay, let me move this across here so you can see the code here, and I can show you what happens when you execute it. Nested functions.py. Okay, it throws name error. Name foo is not defined. Why? Because you need to call this function only when you call testfn. Execution of testfn defines foo. Foo gets defined when you call testfn, right? Let's try to call testfn here. And now do you think foo is going to work? Not yet. Just see what happens. So let's suppose foo is not defined. But you should know that the testfn works because in here, I can just do this. I can just say print in testfn at this moment. And here I'm going to call foo inside testfn a couple of times to show you that this is definitely accessible inside testfn. Well, what do you observe here? Here I'm calling testfn function. And this particular function, when you invoke it, it defines foo. And then you can see the print statement is printed, as you can see that in testfn. And here, the foo function is called thrice inside testfn, and it has no problem at all. But when you try to call it outside, it doesn't work. And I guess you know the reason why. The rule, all definitions inside a function body are scoped locally. I think I told you that. So when I define a function called foo, that function is local to testfn. It's not visible in the outside world. So the variable, or I will not say the use the word variable, the identifier foo that's defined inside this function body, that identifier is a local scoped variable. It's locally scoped, I would say. So it does point to a function object, but the moment the function exits, all the variables in local scope are toned down. It's not visible in the outside world. Some of you might think, can I hoist it? Yeah, you can. You can do something like def foo. I can say you can say global foo, then def foo, and you can hoist it in the global scope. You can do that. That's a very not a good design because it does bring up some lot of surprises to programmers. Where programmers, when they read the code, they don't know what's happening. Suddenly, magically, a function comes up in runtime and then goes away. In your source code, when you look at it, you have to struggle and find out where this function is getting hoisted. Hoisting variables is a bad idea. Or hoisting functions is also a bad idea. But you can do it. There could be some legitimate use cases for it. But it might almost always surprise other developers who are going to read your code. They need to spend more time to figure out what's going on. That's something that you keep in mind. The last thing you want is a developer who is going to maintain your code. Obviously, whatever code you write in organizations, or even if you're building open source projects, it's not confined to your own as your own belonging. Once a code is let in the open, whether to your team in a company or whether in the world in the open source projects, You'll find a lot of others who's going to read your code and try to use them and try to modify them, try to refactor them. The last thing you want is people getting frustrated about that code and trying to say, this is not making sense. So you want to keep it as clean and easy to maintain as possible. And though you can have nested functions, there are other use case for it. There are the use case for nested functions. Now, you can build a factory instead. This is called a factory method, rather. This is just a design pattern, but I'm showing you just with functions. But it just gives you the true essence of what a factory method is. So let me just save this file. I'll call this factory function rather. So it falls in the design pattern of factory method. So when I call it factory method, some people might argue and say, where is a method here? You only see functions. I don't see classes. Yeah, factory method is just a coin term, but the core idea is this. Now let's say that this testfn does not really call foo, but it returns it. You know what I'm doing here? Okay, let me remove the print. Let's avoid that. You define foo inside testfn, but you're not calling it. You're returning it. You didn't call it. You can say return is just foo as an identifier. It's not, there's no call operator being used. You don't see that open close parenthesis here. Because you're returning foo from here, what really will happen if we just say maybe fn is equal to testfn. What is returned by testfn? I get it in the outside world. Then I can call it. Where am I calling it? I'm calling it main under the name fn. When I invoke fn, what gets invoked is foo. In fact, I can put a print statement to just show you that I'm calling it main. I'll just say in main, right? So I can just put it this way. This is an example of a factory method. Why it is called factory method? Unless you call testfn, you won't get fn. You won't get foo. You get access to foo. You can invoke foo only when you invoke testfn. Testfn manufactures the function for you and returns it in runtime dynamically. Wow, that's interesting. Where will you use it? Well, think about it this way. Let's say that I have some, let me completely change this. This looks very silly. So let me completely change this. Let me now define a function. Let's create a function that's called, fetch of URL. And here I'm going to check if URL dot starts with http colon return fetch http. Sorry. Elif URL dot starts with https colon return fetch https. Elif URL dot starts with ftp colon return fetch ftp. A very simple use case. And let's say I define a couple of functions in here, or rather I want to make it more like an abstract factory. So what I'm going to do is I'm just going to call this as a fetch page. I'll define a function called fetch page. Def fetch page of URL print fetching a page using HTTPS or HTTP protocol and return fetch page. Here I'll define the same function name with something else. The body could be totally different, where I could just say fetching a page using HTTPS protocol, which could have a different implementation, but I just put a print statement there. Maybe you have a different implementation to fetch a web page using HTTPS protocol, and I'm going to return fetch page again here. Or if it's FTP, maybe I could just use def fetch page one more time, URL, and print fetching a resource or fetching a file using FTP protocol. I can say downloading a file. It's not fetching, it's called downloading a file. And I can, and see this return fetch page looks so redundant, so I'm going to remove that from here. Just refining my logic. And I can put this return fetch page right up here. That's a problem. Is that a problem? No, I don't think so. I will also use the else clause just to be safe and define fetch page of URL. And this time I'm going to use an exception. I'll just print, say, cannot fetch, or I say cannot understand this protocol. That's it. You can see something interesting here. I'm taking a URL as an argument, and based on what that URL starts with, most URLs start with HTTP, HTTPS, FTP, SSH, it varies, right? That's the URL format. I'm looking for the beginning of the string, which starts with either HTTP, return, create a function, which will print something. But all these functions are looking identical because I'm using simple print statements for simplicity, but you can have a completely different logic implemented in here, which works with HTTP protocol, let's say. Or maybe if it's starting with HTTPS, maybe you need to do all these SSL negotiations. So your code might be a little different for that. So you could have a different code for this. If it's FTP, you can load FTP related libraries and connect to FTP site and download a file based on FTP, right? So that's the function name is same, but there are different implementations based on the condition. So this function gets defined if this condition is true, else this function gets defined if this condition is true. So based on which condition you choose, different variations of fetch page would be returned. And when I call here fn is equal to, I can call it as, fetch factory. It's a good idea to just name it as factory. I say fn is equal to, I say that I fetch factory of some URL. Let's assume HTTP, maybe I can just type /prog.com, for example. I can just type fn2 is equal to fetch factory of HTTPS, / let's try python.org, and fn3 is equal to fetch factory of ftp : ftp.gnu.org, let's assume. And I'm just going to call these three functions: fn1, fn2, fn3. Try running this now. Oh, there's some error, missing argument. Okay. I don't have to. Okay. I think all of these takes an argument here, so I'm just going to ignore the argument for now. Ideally, you should take an argument and do something, but you could prepare those arguments by some other means. But you don't need an argument, actually speaking. You don't need it. Let me remove that. Argument is not required for this. You can see what happened here. I have defined three different implementations of functions called fetch page. So fetch page, you have one implementation for HTTP protocol, another one for HTTPS, another one for FTP. Right now I just put print functions and just print HTTP, HTTPS, FTP, but this is like a boilerplate which you can improvise and really add mechanisms to work with HTTP library or HTTPS library or FTP library and so on, and build different versions of it, right? Now, the way you call it is by a single function, fetch factory. This particular fetch factory, you pass a parameter here based on input parameter, based on input specifications that is to this function, it manufactures a function to that need and gives it to you. And you can use that function. If I call fetch factory one more time and pass another input parameter like HTTPS in this case, it manufactures another function specifically for using HTTPS protocol and then gives it to you. You see where this is going? This is a design pattern, and that's called a factory method. So the core essence of factory method is this. So some people might take up a UML diagram and show you that a factory method must have an abstract class and blah, 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 all those things. That's the Java world. But the core essence of what factory method does is done by this function. I still call this a factory method design pattern the Python way, let's say. Right? So this is an example of nested functions. One of the common example of nested functions are these. There's a common pattern for using nested functions. Basically, you have a enclosed function. This is called as an enclosed function. And this is an inner function. All of these are called as inner function, or some people like to call it, I've been using the term nested function before somebody told me what this is. So I continued using it. It's all the same. So it could be an enclosed function and an inner function here. So the inner function, which is there here, is manufactured or defined based on specifications and passed on to the caller. So the caller can now use that function that is being manufactured just like it. So this is what you see as nested functions are. Now the last thing I should tell you is, I think I spilled over more than an hour, but I hope I have time for this video. Okay, just hang in there, hang in there. I need to go back and visit that non-local scope, isn't it? Yeah. So let me revisit that file where I was talking about non-local scope here. Now it'll become very clear to you. If this enclosed function has a variable defined, I said a is equal to 200. Now here in testfn, if I just type a is equal to 300, so you can see here, let's call testfn this, let's call this testfn, and let's call this foo. That's what I used earlier. So let's continue with that. And let me make it simple first. Let me show you what's going on. Let me slowly grow it up so you'll understand things better. So here I have testfn, and let's say I'm going to call foo also here inside testfn. So when I call testfn at this moment, and when I try to run this code in testfn, a is equal to 100. You can see that the value of a is a global variable. At this moment, it's accessing a global variable. So because in testfn, I'm not printing anything. I'm just defining foo and I'm calling foo. But when I call foo, what does foo access a as? There is no local variable called a in foo. There is no variable in testfn defined by the name called a. So it looks up the global scope. That's the default. So you have local and you have global. But now, if at all in testfn, I create a variable called a, which is the same name as a global variable, right? And I'll make the value as 200. Now this a is a local variable defined in testfn. And in the same function, if I define another inner function, I define an inner function called foo. And in foo, if I try to access a, now you might wonder, what value will it access? Well, let's try it. A is equal to 200. Well, you can see the value. It shows up as 200. What it means is, in this case, this variable A, if you're trying to see, it's not defined in foo, right? This A is not defined inside foo. If it was defined inside foo, let's say if I said A is equal to 300, obviously there's a local variable. This is a local variable. What is this? From the perspective of foo, this A is also called as an enclosed variable. What is enclosed variable? Variable that is in the enclosure. Think of testfn as an enclosure function, which encloses foo, right? And this is obviously the global variable. But the point is, by default, when you try to access any variable in a function, it checks whether the variable is locally defined inside the function. If it is, that will take the precedence, and you will see that that variable is what is resolved. You see 300 here. Let me just run this again. You can see the value is 300 here. What is defined inside foo? That's what you see. But suppose I will just comment it off right now because it's more convenient rather than creating multiple .py files. You should not do this in production, by the way. It's okay for learning, right? I just commented off that variable definition that is. But I'm trying to access A this time. When I try to access A now, what do you think it's going to access? If A is not defined locally, if this function has an enclosed function, we also call this external function or enclosed function, that function's scope is what is resolved to. Now we can see that. I run this code again, it is also 200. Some people might call it outer function. It's okay. You can call it outer, enclosed, external. It all means the same thing, right? It's basically foo is a function, but this function has an enclosure. You can call that as an outer function. If you call this as an inner function, that is, right? Or you can call it an external function. Different terms, right? It's all the same thing. And you can see it resolves to that scope. If this variable is not defined in testfn, then it goes and checks the global variable A. Then it is also global variable A, right? So you can see that the scope of a variable right now is local, enclosed, global. But what if there's no global variable? It doesn't stop there. It checks whether there's a built-in, in the built-in module, is there a variable called A? It tries to check it there. If there is a built-in variable called A, it resolves that. Well, there's no built-in variable by name A, but remember, if you look at, let's say, a lot of built-in functions are there, right? So if you just have functions like print or len and all these are built-ins. You can use it anywhere. See this print. How is this print getting resolved? This print is not defined inside foo. It's not defined locally, nor is it defined in testfn, nor is it defined globally. But where is it getting from? It's getting from the built-ins. So these are the levels by which names are resolved. Names are resolved as local, enclosed or external, you might call it, or outer, depending on what term you use. It's all fine. Okay. If it's not there externally or in the enclosed function, then it checks out the global variable, module level. That's module scope. That's global. If it's not defined in the module, it looks up in built-ins module before failing with an error, name error. So these are the basic concepts you should know related to scope. I know this video spilled over. I think it went on to almost like 1.5 hours. Thanks for watching for so long. If you've been watching for so long, thank you very much for staying back. But I know it's been a little mind-boggling for many of you who are new to this concept of scope, but I want you to explore and experiment with it. But we are not done. I need to create another series of it. I need to create another part. So I'm going to talk about the scope, revisit it again in the next session. But I'll go a little more detailed about interesting features related to scope. I'll give you some examples, and then I will talk about some interesting things. I thought I'll cover lambda calls in this, but I think it's going to spill over to the next session. As usual, if you really like all the concepts I'm covering, and if you're learning something from these videos which I'm making, I know it's a long video, but if you really find this informative or valuable, do support me. Hit the like button, and if you're not subscribed to my channel, do subscribe, and you will also see other videos like this as I post them. You'll get in your notification, and please do comment if you do have any queries or doubts or anything at all, just post them on comments. I'll be more happy to reply to them. And thank you very much. So I'll meet you in the next one.